Hello everyone, my name is Wagari. Welcome to our electrotechnology department and this level 3 course. This unit of competence is called Design and Develop Digital Electronics System. The course has around 100 estimated times or hours, and so this digital platform is prepared to enhance the understanding of trainees, especially for those who have not attended in the classroom during the lectures. And so one can read and also prepare himself for the exam at anywhere and at any places. Here, this is a lecturing 1, the lecturing 2, and the others will be followed by. Before going to that, I wanted to explain as students have to make download and also listen and read the course matters attentively. And also to exercise each types of reflective questions and other problems. Good. Before going to that, I wanted to introduce about introduction to digital systems. Digital system is a famous word in these centuries. The world in this 21st century is going to digital systems. Almost we are come out of the analog systems to digital systems. Good. In science and technology as well as business and others, other field of endeavors, we have dealing with quantities. Quantities are almost related with our long lives, especially in these eras. Things are measured by different quantities. Such types of quantities can be determined by digitals or analog. Quantities are measured, monitored, and recorded, as well as manipulated, observed, or in some ways we utilized it in most physical systems. Almost, let us say, measuring instruments. Physically, we can say something about that measuring instruments. That is called what we call a quantities. It is also important when dealing with these various quantities, we able to represent their values efficiently and accurately. A great matter in there is how we can quantify and also how we know about its accuracies. Accurateness and efficiency is almost another matter with these quantities. So in quantities, we have to specify their values as well as their accuracy. That is what we call that values, and efficiently must be accurately quantified. So there are two basically representing these quantities. Almost any measuring device or instrument value can be quantified as analog or digital. In this case, we can say something it is analog quantities or digital quantities. In terms of that, we can say something whether it is digital or analog. Digital and the analog systems almost can be determined in terms of signals. What is a signal, especially in electrical electronics system or in electronics field of studies, we deal with about signals. What are signals? It should be specified here. Analog signals can be represented. That is what we call analog representation. So in analog representation, quantity is represented by a voltage, current, meter movement, and the other value of that quantities. In analog system, quantity can be represented or displayed by by what? By voltage, current, and the others. We can say voltage signals, we can say current signals. Such types of signals can be quantified and they can be analyzed as analog signals. You can see this type of signals. This signal is a voltage signal irrespective to time. With time, the initial point is 0. The voltage signal is from 0 to 5. Maximum magnitude of the voltage level is 5. And also the minimum value of the voltage is around -5. That is the magnitude of our voltage in this case. The value is continuously increased and also continuously decreased. That is how we can say about the magnitude of the values. So when the values are represented in such a ways and their signals can be determined continuously, such types of continuous values are almost said analog signals or analog values. Almost we can say analog voltage. In this analog voltage is determined in terms of a time. As soon as the time increases, the value of the voltage can be almost from 0 to 5 or from 0 to -5. That is what we call analog quantities. So such types of quantities seated above and below is almost important, and also we have we can get a varied continuous range of values. Such types of varied continuous range of values are called analog values. Good. When we come to digital representation, in digital representation we have digital signals. You know that in this in digital representation, the quantities are represented not only by proportional quantities but by simple called digits. Here, not as analogs, it is continuous values almost. It is categorized in digits, means in some form of digit forms. In analog, we don't know where we are. Almost it is continuous values in digits, but things are almost specified and the digits are represented as that values. It is called digital representation. This quantity is represented not only by proportional quantities, but simple call that digits to say that. So why we say that digital representation. As examples, consider digital watch. Consider your watch. Any quantities displayed in such like they are almost represented in digit, and also provides a time in the day in the form of decimal digits. That means 0, 1, 2, 3, 4. In such ways, to count such types of digits, which can be, we can say in hours, in minutes, in seconds, and so on. Here, as we know, the time of the day changes continuously, but the digits watch reading does not change continuously. Even the magnitude can change it. The magnitude is continuous, but the digit watch reading does not change it continuously because it is a digit, means it is a fixed values. It changes any steps of 1 per minute or per second. So we can say that in terms of that digit. Digital representation of a time of day change in discrete steps. We can say that discrete signals or discrete values. So when we say that, we compare the representation of a time by analog watch. There are ideal reading changes continuously. To say that here, when we say analog, the value is continuously. When we say digit, values are discrete or in terms of a digit. So the difference between the analog and the digital quantity is that in the analogs we have continuous values, whereas in digits we have discrete values. What are the advantage and the limitation of such analog and the digital representations or signals? Almost they have their own advantage and the limitations. In terms of digitals, we have certain advantages. Digital systems are easier to design, especially in this era. Digital electronics and electricals are almost dominant the world because most of the time designing a digital system is easier than that the previous analog ones. The circuits in which are only two voltage levels, because high and low, we can say that whether it is high, whether it is low, it is such types of digits. It makes it easier to design. Why we say that it is easy to design digitals. The numerical value of voltages are not important because they have only logical significance as arranged in this fall is important almost in terms of digitals and analogs. That is a difference between. The other advantage of digital is information storage is easy, especially from time to time the capacity of the memory and the others is almost enlarged and also modified. Digital systems has a high storage and also easily we can store data. Means they have magnetic memories of large capacity that to store that types of data. The other one is accuracy and the precision is great. Almost in digitals, accuracy and the precision is more enhanced. That is why most of the time people prefer digitals. Analog system will be quite complex and the cost is the same accuracy and the precision when we compare with digital ones. Digital systems are more versatile, means whose operation is controlled by a set of stored instructions called the program. It is easy to program the others. Digitals are almost less affected by noise. The main or a big problem in electronic devices is their noise. Noise can disturb users. So most of the time analog instrument and the device are affected by this noise. In digitals, it is more less when we compare to that ones. Here, in behind to this, just own limitation when we compare with analog ones. Almost this real world is not only digital ones. It is most of the time analog and the digital interface. So since this world is in natural cases it is uses analog system, it is another limitation to change that analog into a digital ones. Good. To take this advantage, we deal with analog inputs and the outputs. So these three steps must follow the state that even if there is a limitation, we enforce it ourselves to use digitals because the world and the advantage I have told you before is enforced us to use that one. So the need is to convert analog signals into digital signals. To convert that, the real world the analog inputs to digital form, we need what? Analog to digital conversion system. Process operate on digital information. What can be operated on digital signals? We have to verify such types of information. Convert the digital output back to real world analog form, or such digital signal converted from analog input must be again converted into digital to analog signal, because the real world in our environment is most of the time analog, as we have seen before. So let us see this temperature control system which use analog to digital conversion in terms of its processing techniques. Look that temperature is almost uses analog signals. Our environment, the coldness and the hotness in our surrounding is we call it temperature. That will be get information in the form of analog. So the input is analog signals. There is a measuring device, let us say temperature measurement. So the output is also analog. In case the second process is analog to digital converting system. Why? There is a digital processing at the end. So when we change this analog signal into digital signals, it needs analog to digital converter circuits. It is why we limit the digital signals in terms of this conversion before. So the output is digital signals. This digital signal is given for digital processing system. So this digital signal is given for what? Controllers, but controller needs analog signals. So we need what? Additionally another signal converter, which is digital to analog converter. This the second cycle to convert signals. That is why we say that it has its own limitations. So this gives us analog signals. That analog signal is given for our controllers. Controller we use this analog input and gives it as adjusted temperature signal output. That is almost the block diagram given to illustrate such types of analog to digital or digital to analog signals. Good. The need for conversion between these analog and the digital forms of information can be considered as drawback, as I have told you. It adds another complexity in design and expensive in cost. So you have to understand this one. Another factor for this digital is almost extra time required to perform that. Why? Since there is a conversion, there is a long process, there will be a long time, so it is a time required to do that. In many applications, almost these factors are outweighed by numerous advantages of using the digital techniques. Since digital techniques have many advantages, we omit that types of limitations and the uses that commonly in our worldwide. There are situations almost where using only analog techniques simpler or more economical. Analog is almost to use it is simpler when we compare to that complex designs, but it's more economical because it needs some another systems like signal amplification and others. It is becoming more and more common in both digital and analog techniques employed with the same system in order to profit each, so it needs a conversion as we have seen. In this system we use hybrid system, means mixing of the two one. We use such one, that is how we use a signals and how we can convert one form of signals to the other one. Good trainees, here is a self-reflection or a self-reflective questions. You have to ask yourself and give certain responses regarding to this one. What are we mean when we say analog and or digital one? What we mean when we say analog and digital signals? Name certain electronic or electrical device or unit uses analog signal or digital signals. Which types of signals were commonly used in these centuries and the features? Good trainers, you can support your trainees, and after performing these activities, they can take some break, and we will back on next lecturing. Thank you.